For most of human history, the night sky has served as the ultimate standard for predictability. We observe the planets tracing regular, circular orbits, and we perceive the solar system as a permanent fixture of the universe. In physical reality, this system is a machine that operates on a finite supply of hydrogen fuel. It is currently moving through a sequence that began with a gravitational collapse and will eventually end with the total loss of its planetary population. Research suggests a three-phase life cycle for our neighborhood: a chaotic assembly from interstellar dust, the current multi-billion-year period of orbital stability, and an era where the planets are physically pulled away into the interstellar void. We are living during the Sun's main sequence phase, a multi-billion-year window of relative calm that occurs between the initial assembly of the planets and their ultimate scattering. The process began 4.6 billion years ago when a giant molecular cloud collapsed. This was likely triggered by a supernova shockwave, a massive release of energy from a nearby dying star that forced the local gas to condense. As the nebula collapsed, the conservation of angular momentum caused it to flatten into a spinning disk. Nearly 98. The terrestrial planets are the consolidated remains of this high-energy environment, the result of millions of years of collisions and orbital migrations. In the current era of stability, we can find evidence of ongoing geological activity in the outer solar system. Saturn's moon Enceladus has become a primary subject of research due to its subsurface environment. Enceladus maintains a global saltwater ocean beneath a thick crust of ice. The moon is physically stretched by Saturn's gravity, creating tidal friction that generates enough internal heat to keep that water in a liquid state. This heat drives the water through cracks in the South Pole, called tiger stripes. These geysers eject water vapor and ice particles thousands of miles into space. Between 2008 and 2015, NASA's Cassini spacecraft flew directly through these plumes. This allowed scientists to sample the moon's internal chemistry without landing on the surface or drilling through the ice. Cassini detected organic molecules, salts, and phosphorus, a key building block for life. These findings suggest that Enceladus possesses most of the chemical ingredients required for habitability as we understand it. These plumes demonstrate that the solar system is currently an active environment, where energy and chemistry interact to produce the precursors for biological life. This current state will change in approximately 5 billion years. Once the Sun exhausts the hydrogen in its core, its internal structure will begin to collapse, forcing a change in its energy production. The Sun will expand into a red giant, reaching over 250 times its current radius. During this expansion, the star will likely engulf and destroy Mercury, Venus, and Earth. The expansion will shift the habitable zone to the outer system, potentially thawing icy bodies like Enceladus and Pluto, creating a temporary hydrologic cycle on their surfaces. After casting off its outer layers, the Sun will end its life as a white dwarf. It will be an Earth-sized object with roughly 54% of its original mass, a change that drastically alters the gravitational balance of the remaining planets. The same nuclear fusion that provides the energy for life today will eventually provide the mechanism for the system's thermal transformation and the destruction of the inner planets. Because the Sun will have lost nearly half of its mass, its gravitational hold on the surviving outer planets, like Jupiter and Saturn, will be significantly reduced. Over quadrillions of years, the gravity of passing stars will interact with these widened orbits, slowly peeling the planets away. Eventually, they break free to wander interstellar space as rogue worlds, leaving the white dwarf alone. This orbital structure is a transient state of matter. We are witnessing a specific window of time when the mass of our star and the positions of the planets allow for the stable conditions that make life possible.